Course 1 Math Lesson 43 has a couple long titles to it. Equivalent division problems. You know that word, equivalent, by chance? Equivalent is one that we've maybe had before when we talk about numbers and expressions. It's going to mean the same thing for division problems. Equivalent just means worth the same. You kind of see equa in there, like equals. So if that's easy, just call them equal division problems. We know division problems, so it's going to be two division problems that are worth the same, end up equal. They don't look exactly the same, but they're equivalent, kind of like when we have equivalent fractions. Worth the same, but look different, right? Still equal. And then we're going to find unknowns in fraction and decimal problems. Fraction and decimal, what do they have in common? They're both describing parts of a whole, right? So let's dive into lesson 43. If I have this problem that's in the box here, 700 divided by 14, it's a division problem, right? It looks kind of hard to do in my head, but I'm going to say we maybe can do it. You know, we can solve this without a calculator. And you say, what? How could that be possible, right? It'd be a great thing, but how could I accomplish that? Well, if I had 700 over 14, which is the same thing as a fraction, bar means division, I might not be able to solve that, but I can make it look different, right? I see even ending numbers, 0 and 4, so that means I can divide them by 2. And in our mental math, we've practiced doing things like, what's half of 700? That'd be 350, right? So think of this division problem kind of like reducing a fraction. Instead of trying this problem, let's try dividing both numbers by 2. And as long as I do it to both of these, divide by 2, then it's equivalent, and it's going to still be the same answer. What's 14 divided by 2? Okay, so kind of like we reduced it down, let's reduce the division problem down. Does this look easier at all? Is this a little bit simpler? Well, I see 35, forget the 0 for now, divided by 7. What times 7 is 35? Right? Then we toss that 0 back on. Answer is 50. Go ahead, check 700 divided by 14 in your calculator. Answer should be 50. We can do the same thing to this division problem. Make it different, make it equivalent, and thus able to solve without the help of calculator. Let's pretend our calculator's gone that day. Mr. Otto's making us do the problem without it. Instead of throwing up our hands and saying, I can't do it. Instead of dividing both numbers, we're going to multiply. What could we multiply these both by to make them just a little easier and possible mentally? I don't like a half, so let's times that by 2 and make it 1. Okay? And if I'm going to times that by 2, let's just see what happens if I times this by 2. 7 times 2 is 14, but then this times 2 will be 1 added on to that. 14 plus 1, 15, divided by 1. Well, that's just 15. Let's double check it with 7.5. That's the same as 15 over 2, I believe. To divide, we multiply by the reciprocal. You can cancel across. 15 times 1 is 15 over 1 is a whole 15. Same thing, see? So equivalent means worth the same, but a lot easier to do than this guy was. Do this one. Let's try it with this. 1200 divided by 16. How could I make this problem simpler using something equivalent? Create an equivalent division problem that I could solve much easier. If it helps, think of it as a fraction. 1200 over 16. I can't just get rid of these zeros because there's not zeros down here. Can't just do that. But what would be the equivalent? Let's try easy. Divide them by 2. I don't think multiplying is going to make these any easier. They're pretty big. But what if we divide both by 2? I can do 1200 divided by 2. And now I'm dividing by 8. Still don't love that. I'm not seeing something that if I take off zeros, I can add zeros later on my solution, my quotient. I think I still want to make this look different. Divide by 2 again. 600 divided by 2 is 300. I'm still going, because I don't like this either. Let's try dividing both by 2 again. 150 divided by 2. How about that? Can we do this problem now mentally with this equivalent division problem? 150 divided by 2, or 15 divided by 2 would be 7.5. That's because of this. Let's move that decimal over 1. I think it comes out to 75. Feel free to check this on your calculator. And now, instead of doing that, maybe I could have divided by 2, 2, 2. I could divide it both by 8, maybe? Would 8 have turned that into this? So it doesn't take this many 2's, but it's hard to know that right off the bat. Let's see what the book has for us. This is example 1 on page 226. Sure enough, 8 goes into 675 times. Several equivalent division problems can be formed. Whichever one you could have done in your head, choose it. But go all the way down if you have to. 150 divided by 2. Form an equivalent division problem for the division problem below. Then calculate the quotient. We kind of did that one. No, we didn't do this one. We did this one before. But what do they do with 7.5 divided by 2.5? What do they do? 7.5. Whenever I see halves, I think, what if I multiply these by 2? Won't that be a lot easier? And that makes this one 14 plus 1 is 15. Starting to get used to 7.5 times 2 is 15. 2.5 times 2 is 5, right? 2.5. So 15 divided by 5 looks a lot easier. Equivalent division problem. Why don't we find unknowns in a fraction and decimal problem? Since lessons 3 and 4, we've been practicing finding an unknown number in arithmetic. Beginning with this lesson, though, we'll find unknowns in fraction and decimal problems, not just whole numbers. So they're saying we've done this before. And maybe you're thinking, okay, if I have d minus 5 as being 3, kind of interesting. I take away 5, I get 3. Well, this must be bigger than 5 to get a positive number. How much bigger? 3 bigger. So d is, what? D is 8? How did I find that? Maybe you don't have to think it through, but you took this plus this equals this. And we can check it on our calculator. Now, what if we made this just a slightly different problem with decimals? What if I said 3.2? Is that so scary? How did I solve before? I added this plus this. And we've learned how to add, maybe with a 0 here to line everything up. We've learned how to add decimals. So if we follow the same format, add your subtrahend and your difference, you should get that minuend. Check it in your calculator. Does 8.2 minus 5 equal 3.2? I think it does. So even if it's a decimal or maybe a fraction, like let's try 3.5 plus x equals 3/4. How do I solve these? And I don't like this one very much. Let's make it 7 3/4. That might be a little better for our first time. Something added to 3.5 will be 7 3/4. So what is it? How do I solve these? I take the sum, I subtract one of the addends, which is the one we know. It should give me that question mark, that x. And we can check it later by plugging it back in. Subtract your whole numbers first. 7 minus 3 is 4. Subtract 3/4 minus 1/2. Change this to 2/4. 1/4, because we keep our denominators to we don't change them in adding and subtracting of fractions. So that goes over here. Don't lose track. Keep things organized on your page, not like me here. I got all sorts of things on the same page. 4 and 1/4 is what I'm thinking. We'll make this add up. You could check it with your manipulatives. We could check by adding that. I think that's going to work. I think that works out pretty well. Let's take a look at what the book had for these. They did the 5 plus 3 and 2/10. They do f plus 1/5 is 4/5. Real easy. They don't have even different denominators. So what plus 1 is 4? 3. And then keep it over 5. Multiply. 3/5 times what is 1? That's a reciprocal problem, isn't it? Reciprocals tell us any fraction times its flipped version or reciprocal will be 1. You can check it by putting 5/3 in here. Do a lot of canceling and end up with 1. Why don't you pick A or B and pick 2 from here? So you're doing 3 total problems. Good luck.